Hello class. Today we will be discussing about a topic called as graph, which is coming under unit 5. And in graph, we will be discussing about graph traversal topic. So before getting into this graph traversal, it's very important to understand what graph is all about, right? So let me just quickly show you a diagram to make you understand what is graph. And so everybody will understand the definition of a graph. So you don't have to by heart what is the definition of a graph by just looking at the explanation. But I want you to carefully listen by looking at this particular graph. So this is actually called as a graph. This is how the graph will look. So it has these circles. Can you see these circles? How many circles do we have? That is 1, 2, 3, 4, 5. 5 circles we have. These circles are called as vertex. Can you see that? It's called as vertex. We will not call it as circles, but then we will call it as vertex. You can also call it as node. Instead of vertex, you can also call it as nodes. These circles are either called as vertex or it can be called as nodes. Now we have all these nodes and vertex. Now it has to be connected or it has to be linked. Then only we can call it as a graph. So how it will be linked? It is linked using these lines. We will not call it as lines, but then we will call it as edges. So we have two different terms in a graph. One is called as vertex. The other one is called as edges. So vertex can also be called as node. That also you have to remember, right? So how can I give the definition of a graph? If I ask you, tell me the definition of a graph, then you can simply say graph is actually a collection of vertex. It should be connected with edges. So mathematically, how can we write the definition of a graph? We can simply write this particular equation telling G of V, comma E. It's very simple. G stands for graph. Yes, you are right. V stands for vertex and E stands for edges. So this is the mathematical representation of a graph, where graph is actually a collection of vertex which should be connected using edges. Right? Now tell me what is the what is the other name for the vertex? Yeah, you're right. I can read your minds. So it is called as nodes. Right. So I'm sure everybody understands the definition of a graph. Now coming to the next topic, that is what we are discussing about. That's called as graph traversal. Because you understood what is graph, then slowly we will move to the next topic, which is called as graph traversal. What is this graph traversal? Traversal comes from a word called as traveling. You have to travel or visit every node, right? Node in sense vertex. Let me just show you the diagram again so that I will make you understand what traversal is all about. What is this traversal? You have these nodes. Now you basically travel across every node exactly once. You have to visit all the nodes exactly once. That is called as traversal. Now you can visit like this: A, and then B, and then you can visit E, and then you can visit D, and then you can visit C, and so on. But you have to visit every node in the graph exactly once. Now, how to identify the path, or how to identify the sequence of the visit? That can be understood using a concept called as BFS and DFS. This traversal will have two different techniques. One is called as BFS. You have to identify using BFS technique how is the visit happening. But both the concept BFS and DFS both will give us an order where you have to visit every node exactly once. But the order differs or the path differs. The visiting, how we can visit, that differs. So let us try to understand what graph traversal is. I've given the definition. I'm not going to do the reading part of it. You will be doing the reading part of it. You have to visit every vertex in sense node in a graph, usually in a specific order. The order can be decided using these two techniques. One is called as breadth first search, and the other one is called as depth first search. Right? These are the two techniques. In this particular video, I will discuss about what is breadth first search, and then in the upcoming video, I will discuss about depth first search. For both the techniques, we will try to solve a problem so that it is kind of easy for you to solve in the examination as well. Right? So let me just quickly discuss about breadth first search in this particular video. In the next upcoming video, I will talk about depth first search. So I want you to quickly take a piece of paper and get your pen, and then we'll start understanding what BFS, which is called as breadth first search. Right? We'll call it as breadth first search. Now, how exactly this particular technique, given a graph or a tree, whatever, right? Given a graph or a tree, how this, how the visit will happen. You have to identify the sequence of the visit. In breadth first search technique, the visit will happen level wise or breadth wise. It will visit. So imagine this is the 0th level. This is the first level. This is the second level. How the visit will happen? It'll start from here, and then it will go to the next level, visit the nodes of the next level, and it'll move to the third level. The third level instance is second level because we started from 0. So it'll move level wise. It will start visiting one after the other, and that is why it is called as breadth first search. It will search breadth wise, and you know it'll go to the next level, search the entire breadth wise, and visit every node in the given graph or a tree. So this process is called as breadth first search technique, right? Now, the second thing that you have to remember is BFS uses a concept of a queue, right? Queue is one of the data structure concept. If you don't know what queue is simply like an ID card queue. If you are a student, I'm sure you have an ID card, center where you will be going to the ID card center and everybody stands in a queue for the ID card. So there is a first student. If he is standing at the counter, he will be served first and he will leave, and then the next student will be served. He will leave and whoever is standing next will be served. So I can tell the queue will follow a principle called as first in, first out. Whoever came first will be served first, and then he will leave first in, first out. So these are the two major points that you have to remember when it comes to the topic called as BFS. The first point is it will always, visit level wise or search level wise or breadth wise. It will visit. And the second point that you have to remember is it uses a concept of a queue while solving the problem. We will use a data structure. What is the data structure that we will be using? That is queue. Now you know what is the principle of a queue. The logic behind the queue concept. What is the logic behind the queue concept? Like a normal queue. Whoever comes first will be served first. So it is first in, first out. He came first, he will get the service done first, and then he will leave. So these are the major 2 points of BFS. Now we will try to solve the problem. Did you take the piece of paper and pen? Let us try to solve BFS problem in graph traversal. The question will be given. You don't have to by heart any of the graph or not. The graph will be already given in the question paper. It will be also mentioned. Please solve using BFS technique in graph traversal. So 0 node. You can also draw with me. This is a node 1, and then node 1 is connected to 3. And it is connected to 2, and this is connected to 4. Okay, this is the graph that we will be working on. I want you to carefully listen on this particular simple graph. So any given graph you will be able to solve BFS, right? So the first thing that you have to remember is this is the question that is given. In the question, if it is mentioned, please start from the root node 3, then you have to start the process from the root node 3. If it is mentioned, please start from the node, or considering 2 as your root node or the first node, then you have to start from 2. If nothing is mentioned, you can start from wherever you feel like starting, or you can consider any node as your first node. Okay. So the question is given. Now the next thing that you will be writing is called as result. Right. I will be writing or printing the result over here. Right. So let me also write it as print. Print the result on the output screen. Right. Now we also have a queue. I said BFS uses a technique or the data structure called as queue. The queue is ready. Now let us start. Look at this problem. Did I mention where we have to start? In this question, nothing is mentioned. Where to start is not mentioned. But in certain questions, it will be mentioned. Please solve BFS considering 1 as the root node. So you have to bring 1 into the queue first. If it is mentioned 3 as your root node, then bring 3 into the queue first. Or if nothing is mentioned, it's your choice. You can start from wherever you feel like starting. So because my favorite number is 0, I will start from 0. 0 the hero. So I want you to carefully listen. So I selected which number I am going to start with, 0. Now take the 0, bring it onto the queue. Right? Bring it onto the queue. Now there is no other element in the queue. Only 0 is the person waiting to be served. So it got served. So basically it is got the service done. Now it has to leave the queue. There was only one number, 0, and then 0 got got processed, and then now it has to be displayed on the output screen of the result. So I'm writing 0 over here, processed, and wrote the result, printed the result basically. And now what is the next thing that you have to do is try to identify the adjacent nodes of 0. What is this adjacent nodes of 0? Try to identify the nodes that is connected to 0. 0, or you can also understand in this way. See the lines that is going out of 0. How many lines are going out of the 0? Yeah, you're right. 2 lines are going out of the 0. That is 0 is connected to 1. 0 is also connected to 2. So 0 has 2 adjacent nodes that is called as 1 and 2. So I will call this 1 and 2 as friends of 0. Right? 0 has 2 friends. Who are the 2 friends? 1 and 2. Bring those both into the queue. 1 and 2. 1 and 2 are friends of 0. How it became the friends of 0? The adjacent node. Just see 0 and what are the lines that is connected to 0? That is 1 and 2. So bring both these into the queue. So 1 is there and 2 is there. Now who is the first person that is on the queue? 0 got served and printed. The result was printed over here. Now who's the first person who is in the queue? That is 1. Okay. Process the value, that is 1, and print the result. What is the value that will be printed? 1 will be printed. Now try to identify the friends of 1, right? Or the adjacent nodes of 1. Look at this particular node. Try to identify the adjacent node. Very simple technique. See the lines that is going out of 1. There are 3 lines that is going out of 1, right? So 1 is friends with 0. 1 is friends with 2. 1 is friends with 3 as well, right? We will not call it as friends. Friends, I am using the term called as friend because you can understand better. But then we will call as an adjacent node, right? So one's adjacent node is 0, 2, and 3. Now see, we have to bring these people into the queue. 0 is already in the queue. Don't invite them. Don't invite the 0 because 0 is already in the queue. Already was there in the queue and left the queue. Now 2 is already in the queue. Can you see that 2 is already in the queue, right? Now, who is not there in the queue? Oh, this friend does not come to the queue. So, let's pull 3 into the queue. I hope it is understood. Right? Now, who's the first element that is there? 0 went, 1 went. Now, 2 has to be served and the 2 will be printed on the output screen. Now, we'll try to identify the friends of 2 or adjacent nodes of 2. Who are the adjacent nodes of 2? See the number of lines that is going out of the 2. Okay, there is 3 lines that is going out of 2, correct? So 2 is friends with 0, 2 is friends with 1, 2 is also friends with 4. So basically 2 has adjacent nodes that is 0, 1 and 4. Right. Let's try to bring them to the queue. We'll call them to the queue. We'll see. A 0 was already in the queue. Okay, 0 already got a chance to be in the queue. Now 1 also got the chance to be on the queue. Now 4 didn't get a chance to be on the queue. Can you see that? 4 didn't come to the queue only. Okay, bring that 4 into the queue. The new friend came into the queue. That is called as 4. Now come to the queue. Who is the first person on the queue? That is 3. Process the 3. Print the result onto the output screen. Okay, this let's assume is an output screen. 3 is being printed. Now try to explore the friends of 3. Try to identify the friends of 3, adjacent nodes of 3. Okay, how many lines are going out of 3? There are 2 lines that is going out of 3. 3 is connected to 1 and 3 is connected to 4. Okay, these are the 2 friends of 3. Now let's try to bring them into the queue. Let's see. Hey, one was already part of the queue, so just cancel it off. Don't bring that one. Now 4 was also 4 is also there, currently there in the queue. Okay, already got a chance to be part of the queue. So nothing is there. Who are the friends of 3 who can be pulled into the queue? No worries, no issue at all. Right. Now let us see who's the person that is there on the queue. Is there anybody on the queue? 0 went, 1 went, 2 went, 3 also went. Now remaining who is there? 4 is there. Let's process the 4, print the result onto the output screen. Now try to identify the friends of 4. I'll write over here. Friends of 4. Okay, let us try to identify how many lines are going out of 4. Okay, there are 2 lines that is going out of 4. Okay, 4 is friends with 3 and 2. Adjacent nodes. What are the adjacent nodes for 4? That is 3 and 2. Let us try to bring them into the queue. Right? If it's already part of the queue, don't bring them into the queue. 3, yeah, it got a chance to be in the queue. See here. And then 2 also got a chance to be in the queue already. So there is nobody that has to be pulled into the queue. That's all. There is nothing else that is remaining on the queue. Can you see? When you went back, everybody got processed. 0, 1, 2, 3, 4. There is nothing in the queue. So basically, we visited all the nodes. We visited 0, we visited 1, we visited 2, we visited the node 3 and 4. We visited all the nodes exactly once. And what is the order that or the sequence it followed using a technique called as BFS? That is the sequence is 0, 1, 2, 3 and 4. This is the result. I know the output using a technique called as BFS, which is called as breadth first search. I'm sure you understood. If you didn't, then rewind the video and then try to understand what exactly I was trying to explain. If you have any doubts or if you have any questions and all that, you can definitely post it across to that email ID. I will be very happy to help you in solving the problem. Right? Thank you so much.